So this is the first time we're trying here in remote presenter. And first of all, thanks to Voice for inviting us. It was a bit last moment. I can get my friend Rodrigo to fly in from Mexico. It doesn't work out. It seems like he cannot go back to another meeting in 8 hours in Mexico. So he had to stay there for business reason. We will try the first part of the presentation will be delivered by him. And he's here. And then I'll come in at towards the end when the CEMEX presentation has been there. We'll just try it for one more second to see whether everything is working. So with that, Rodrigo.
Thank you, Prabal, very much. Thank you, everybody, for hearing me this way. I know this is very awkward. I was not planning on doing this, but this is a very welcome opportunity to experiment new things in Pi world.
Come here.
We're loving to do this kind of experiments with the Pi
Come closer,
system, and
guys. He
why
wants to
not
see you.
with
So.
video presenting in Pi world. So let me begin with saying probably some of you know CEMEX and Petuum, probably you don't. So for those of you who don't, let me just say a little bit about CEMEX, who we are. We're a global building materials company that provide products and services to customers globally in more than 50 countries throughout the world. We have annual sales close to $14 billion, and we are one of the leading cement manufacturers, ready mix, and aggregates globally. Next slide, please, Prabal. Myself, within the global operations and technology group. I take care of the digital technologies for cement operations. That includes uh, processes, tools, procedures, and of course, the Pi platform, which is the cornerstone of our digital foundation for all cement operations. Prabal, I don't know if you want to introduce yourself.
Well, I'm not that important here. Continue with things. I'll come back when I have my session. Please continue.
Or, thank you. Let's go a little briefly through the agenda. We have a lot of material, so I want to be very brief on the initial slides so we can cover more deeply the more interesting slides towards the end. First, to talk a little bit about artificial intelligence use and its potential for the cement industry, and how we got started on the path to artificial intelligence. How Petuum Industrial Autopilot works, and how it has been applied in our cement operations in CEMEX. And also, how do we deploy and what's the architecture integrating OSIsoft Pi into it. Next slide, please. So how did we go through the digital transformation journey? We began I cannot say a couple, many years ago, more than 10 years ago, on digitization. We had all the sensors and all the technology, all the signals. We have Pi systems in every single production facility. That's close to 60 facilities around the world. And in all of them, we have Pi, and we are collecting data in there. So what happened after 10 years, or more than 10 years that we have the platform, we have tons of data. And they say data is the new gold. We have a gold mine sitting there, and we were not tapping it. So the next step was to try to see and understand what was happening in the processes. We have been doing that manually and doing a lot of visualization, but not really having a deep uh, analytics capabilities. And that has started only a couple of years ago, and that's part of the boom of the industry 4.0. And then once we have all of that, since we already have more knowledge of our process and we are getting some prescription and some recommendations from our analytics, then we are moving towards let's feed that directly into the kiln. So in a way, we're moving forward an autonomous operation through artificial intelligence. Next slide, please. So why artificial intelligence? I know it's a boom right now. Everybody's talking about it, but in reality, we do think it holds the future for growth and success. In the cement operations, artificial intelligence can help us realize some improvements or achieve goals that are very hard to achieve manually. I mean, it takes a lot of effort to be uh, the best or striving to be the best. So we need all the tools and all the help we can get in that, and that's being applied in safety performance, in operational efficiency, in energy efficiency and fuel efficiency, and of course assuring quality and or during our product design. Next slide, please. So we began this journey probably 2 3 years ago, and we set a goal. We said we want to have an autonomous kiln by year 2022. Probably we're going to get there faster, but the idea is this is not a 100-meter dash run. This is like a marathon, and we need to be working towards that vision slowly, but with very hard steps toward that goal. Why? Because we need to increase our efficiency, to have better products, to have reduced cost. In the end, we need all the new technologies that can bring us better decision making, not only in our process optimization, but also in other areas like failure prediction or uh, cost efficiencies, in safety, performance, in every possible way that we can use it. Please, Prabal, next slide. So why did we go to with Petuum? Because we had the opportunity to start in a collaborative approach and engagement. We wanted to test the technology if it was possible to use artificial intelligence to bring the benefits that we were thinking or that we were reading everywhere that the technology could bring. And also, Petuum had the ability already in their organization, but they were not big in industry, in the process industries. So this was like a match made in heaven, and we had the opportunity to work together, both learning from each other. And we decided to go through a phased approach. The first approach was, okay, let's first show me predictions. I want to know what's going on in the process, and if that's going to how is the process behaving and how it's going to behave in the near future, to have a better understanding of our process. Second, since we already had those, we wanted to get from the artificial intelligence model recommendations. We already have the prediction. We knew how the process was working. Now we wanted to get predictions from the system, or prescriptions from the system. Like when you go to a doctor and they say, well, you need to take this medicine if you want to get better. In this case, give us the prescription to improve our process or how to operate our account. And the third one is after we tested those, if we were getting the good results, let's feed them directly to the system. And that was the very first step towards an automated kiln operation. Yeah, next slide. So we decided to test this in one of the processes within the kiln system. The kiln system, as you can see in the picture, it's a huge system. We have material coming from the upper side, uh, preheating through the preheater tower, going down to the kiln. The kiln is a rotary kiln, so it's turning continuously, and then the hot material is coming out through the cooler. In the cooler section, we have it, as the name implies, is for cooling the hot material, and we are pushing a lot of cold air into the system to recoup all the excess heat from the hot material back into the system for process efficiency. So we decided to divide the kiln because it's a very complex process. There's a lot of complex chemistry reactions, chemical reactions going on in there. So we decided to go with a very, I cannot say simple, but the simpler process of these sections, or the simpler section, and that was the cooling section. And how that was, the objective was to increase the amount of, or to optimize the heat recovery. In this case, controlling all the input of fresh air and the cooling rates. That's how the clinker moves inside the cooler until it exits the cooler, and to measure that our process variables are stable, and of course that our product quality remains optimal. Next slide, please. So we started with our phase approach. In the first phase, as I was mentioning, we had the forecast prediction in real time, the capability to have an additional piece of feedback to the kiln operator saying, in the next 5 to 15 minutes, your process is behaving like this. And as you can see in the pictures, these were my eye-opening for all of our kiln operators, because for the first time, they were able to see how their process was behaving and how the artificial intelligence model was telling them the system was going to behave 15 up to 25 minutes ahead of time. The longer you want to do the prediction, the less accurate it is. But 5 to 15 minutes is good enough time for them to realize if the system is cooling, if it's heating, if it's too unstable, and what, based on their experience, they can react ahead of time to have a more stable process. In this case, as you can see, all the actions taken from the recommendations are based on the kiln operator's knowledge, on their experience and their intuition. We have very experienced guys, but that's not always the case. And the most experienced guys or the persons operating kilns are not there 24/7. So we want this system to help our operations get the golden days of operation, to have the best output on a 24/7 basis. So that was the very first stage. In the second phase, what we did, next slide, please. Thank you. Since we already knew or had more knowledge on how the process behaved, we started getting some recommendations in real time and say, okay, give me how would the system operate the kiln. And instead of giving us simply point one, move 20% up, point two, move it down 20% down, point three, use it as it is. Instead of that, we needed some visual aids for the operator. So in this case, we built in PyVision. That's part of the beauty of this collaboration, is that we didn't use anything that was not familiar to the operator. We used PyAF, we use PyVision. So we're using the tools that people are used to work with, and that's within the OSIsoft platform, within the Py platform. So we started getting some recommendations and some visual aids saying, okay, you in the last 8 hours or in the last 24 hours, you have been working in this range, and my recommendation is on par, or is it above that range, or is it below? So that gives some visual feedback to the operator saying, is the recommendation reasonable? Should I follow it or not? So with this additional information, now the operator can fine tune his operating decisions, or even better, start trying the recommendations from the system. So the system was giving them recommendation, and out of curiosity, they started plugging them into their control system to see how it happened. And it behaved very well, actually. So then we moved on to the third phase. Prabal, thank you. So the third phase is, since you're already giving me uh, the forecast and you're giving me recommendations, and we tested them out and they are working okay, let's feed them directly to the system. So we started doing some modifications to our OPC interface for it to accept the signals from Pi, and we started feeding the recommendations back to the control system. So now we had an section of the kiln running in auto steer. That was the very first step, and this was done last year. So we've been running like this for almost a year now. It's been giving us great results, but also very good learning opportunities in how to deploy and what changes to apply when we move to other sites. In this case, it's just like when you're driving your car. You want to turn on the auto steer and you just focus on steering. But all the acceleration and slowing down, there's an additional car coming in front of you. That's happening internally within the car. It's the same case for the autopilot. So now the operators, they know they can rely on that and they can focus their attention on other parts of a process that requires their attention. But in any case, if they see something weird going on, or they see a process disruption, they can switch the autopilot off and continue operating in manual mode until the disruption goes away and then turn it back on. Prabal, if you please. Thank you. So in this brief example, you can see the how the once we start operating the autopilot, the secondary air, which is the main uh, duct of air where we are recouping the excess heat, started ramping up. This was again, it was a great experience when we saw that for the first time. It's like an eye-opening experience for all of us, and that proved that the technology is there and it can do this for us. Next slide, please. So what came next? Now is phase 4, which is to start deploying the proven use cases to other sites. What did we do in this case? We started with, I mean, one of the advantages of Pi is that we leverage other Pi infrastructure. So we have AF and analytics to configure the site. Plus, there's the AI pilot product from Petuum. Then we have all the Pi Vision visualization for autopilot for the phase deployment, in forecasting and in prescriptive recommendations. And then we also do some additional tweaking in the control system. This is outside of Pi, obviously, but it's the work that the plant needs to do to adapt its control system to accept all the signals from Petuum via Pi. And also we also follow up on the performance using additional tools, also Pi based, to see if the models are performing, what's the economic benefit we are getting from the system, and so on. Next slide, please. So talking about achievements, in phase 1, we successfully predicted the clinker and air temperatures and the trace slope the train slope changes up to 15 minutes in advance, reliably. I mean, we could go longer, but not as reliable in this case. Phase 2, we have the prescriptive recommendations in real time, and this will relate to the kiln operator. They made improvements, and we are continuously improving the model based on our experience. For phase 3, we successfully ran the cooler using artificial intelligence. This is an industry first. We did it. That's why I put the calendar in there, because we did it successfully last year. So from November 27 until today, almost 10 months running on autopilot, and it's been a very good experience. And now we're moving on to phase 4, in which we have replicated the models or the autopilot models in other sites. We're doing this in our 5 regions globally. Next slide, please, Prabal. So for now, Prabal is going to tell you how the technology works for Petuum.
Thank you, Rodrigo. By now, you all have a lot of questions and all. I'll like you to, when you ask those questions, use the microphone so that he can also hear you at the same time. And thank you for being patient, letting Rodrigo speak on the remote. I'll be very brief. I want to go back to Rodrigo talking about his experiences and some of the questions. We come from a pedigree of academics. We started with the AI platform. And as Rodrigo said, that the CEMEX and Petuum was match made in heaven. They're looking for something that they can work with, collaborate with for a longer time. And we were also looking for a partner or a customer that can work with us. Because this is hard work. I mean, as you can see, we're taking real systems, whether it's a chemical, metals and mining, or cement. These are big operations. Industrial IoT and industrial AI is hard. And so we've been very fortunate to have been here. We use building blocks to build this thing, so that's why when he's talking about the multi-site deployment, multi-models, it's easier for customers to go to that step. So in brief, the technology behind this is the Petuum Industrial AI pilot. It's a product delivered as a service, software as a service to them. It runs from the cloud, goes back. We use all the OSIsoft technologies, including OSIsoft Cloud Services, Pi Cloud Connect, and all to connect those two. I'll come back to that later. But I would like you to point to three things here. The phases that Rodrigo was talking about also aligns with our modes of our platform. The predictions, as soon as you start sending the data from your Pi system or the context from your AF, you can, in few weeks, you can start seeing some of the key variables in your operations getting predicted, 5 minutes, 15 minutes, 25 minutes. And if you're an experienced person, like when you're driving, and you're driving on the same city for so many years, you look at your Google Maps and it says there's a traffic jam in front 10 miles from yours or something. You don't need the direction to go which way. You know that if there is a traffic, I know which road to take. So that's kind of the prediction helps with the experienced operators. They can really know if the ampere is going down for a kiln, what to do next, and there. Prescriptions is the next steps where we can prescribe something to make it more easier for them to type it in, and then auto steer when you send it back to the control system as set points so that we can, it's like the car's auto steer, as Rodrigo said. On the bottom of the things, you'll see the runtime or the Petuum Industrial runtime. That's our platform, and that makes that magic happen with all the models and everything, getting self-learning, retuning. And as a software as a service, we make it very easy for them, for the customers to go through this as a service so that they don't have to worry about, a lot of linear models lose things so that you have to go and redo that. It's part of the service. It's automatically gets done. All the data sources and all is all connected. We have direct connectivity with Pi in many layers. The next one is typical architecture that we used for CEMEX. In this case, we used Pi in both sides. We used the Pi Cloud Connect to connect, and also on all for the disengagement rules, all the AF analytics. It's actually installed on the CEMEX side. And I think Rodrigo will come back and say having that Pi infrastructure helped both of us, both of our companies very easily, whether we are on a site in US or in Mexico or whatever, and you'll see that the same infrastructure helped us in going, crossing that boundary called IoT or industrial IoT so that we can concentrate on what we do best, which is AI. And what they do best is to make cement. And so that's that. We can go in more detail, and come and talk to us from the product side. And then this three modes. So once you have those three modes, it is almost like having three different products. So just making sure of that. So some of the customers are actually running it only on the prediction mode. In fact, CEMEX, when we were doing the kiln ampere and all, the operators were running it by looking at the second screen. So it's not, and that's the cooler, some of the things that we come up with. We work with customers to set that, but it's customized for your operation. So it's not a set thing that if they're using maximizing of secondary air temperature, you have to do that. And I'll let Rodrigo go through this benefit statement.
Sure, very good, thank you. So regarding challenges, we wanted to obtain a predictable, repeatable golden days of operation. It means what our best operators can achieve in one of their golden days, to have them repeated 24/7 throughout the year. So to have high yield, high quality at low cost. Secondly, to prove the artificial intelligence and machine learning capabilities to optimize our production processes. We had very complex, high variable operations, and we had no real-time prediction, and the operators were always reacting to whatever was happening. They had no proactive way of knowing how was the system behaving, other than just their intuition and experience. The solution, it was the mixture or the taking advantage of Petuum's industrial AI pilot, autopilot product to deliver us the real-time prediction and prescription and feed them back to the operation. And also a huge advantage in this case, the integration with the OSIsoft suite of products. Why? Because it made the configuration, data streaming, visualization, everything was very easy to deploy. If we wanted to connect that directly to our control system, we would need to uh, develop or integrate with many different systems. In this case, we're only talking about one single interface, and that's all OSIsoft standard. So that's a huge advantage. The benefits, we expected the yield and energy improvements by 2 to 7% from combined autopilot use cases. That leads to cost reductions from the energy recovery. In one of our test sites, the first place we tested this out, we had a delta T, an increase in temperature of the secondary air of 55 degrees Celsius. In the case of Mexico, our second site where we deployed the system, we are getting 47 Celsius degrees. For tertiary air, we are getting better results in Mexico than the US. The secondary air is more important in this case than the tertiary air. And for clinker temperature, even though it did not decrease, it increased a little bit, but we're getting a lot of heat recovery. The other thing is that we were able to reduce the process variability by half of a standard deviation, or we took the standard deviation of our variables to half of their values, comparing when we are using the autopilot to compare to when we're running manually by the kin operator. And something that I'm not showing here, and I was just working on this last night, the yield, for example, in the Mexican side, we're getting a 5% increase in yield while we are producing using the autopilot compared to not using the autopilot. So on top of getting better heat recovery, we are additionally getting additional yield. So if you combine those two numbers together, if we were running at the same production rate, probably the heat recovery would be higher. In this case, we're using part of that heat recovery to increase our yield. So that's very, I mean, once you factor in this, the numbers multiply very fast, and this is a big benefit. So what I can say that this is a giant step in digital transformation towards the safe, highly standardized operation, and that will help us strengthen our high quality products portfolio while ensuring we meet operational and sustainability goals and also minimize costs. This is huge for the industry. Next slide, please, Prabal. So lessons learned. One is you need company commitment, both from the corporate side and the plant leadership. This is key to successful implementation. You cannot do it alone. You need all the teams, both from the local teams and from the corporate side and regional leadership to be committed with this project. And also, obviously, the commitment from Petuum. We already have plans to continue our regional deployment. We are already successfully working in two of our regions, and we're moving forward with Europe next month, and we expect to start South America and EMEA by the end of the year. Secondly, artificial intelligence is not magic. Don't expect things to work seamlessly and automatically when you turn it on. You need a subject matter expert input in there. You need resources, and most importantly, you need reliable sensors. This has proved challenging to us because in some of our sensors are very uh, prone to failures because of high temperature applications. So we're adding some redundancy in some sensors to keep our models running the most of the time. Next slide, please. Third, change management is critical. You cannot go on it alone, as I was saying. You need to have the operators take their time to embrace the technology and start using the product. That's why the phased approach was very important. You cannot go directly with phase three, even though we have had a very good success in getting to autopilot. You need to go to phase one, then phase two, then phase three. Otherwise, the operators will not take ownership. So a good change management process is key. Uh, in our case, CEMEX has a center of excellence and Mexico's C3 to provide process support. Also, there's process teams or process support teams that provide the subject matter experts to customize our models and fine tune the differences between one plant to another one. And we are also taking advantage of Petuum's live tracking and alerts to see if there are process disruptions or data disruptions that avoid us from using the pilot because we want to use it 24/7. And finally, the continue, and that's part leads to lesson learned number 4, which is continuously monitor the model performance. Sometimes there are process disruptions that even the best models can start to drift and thus not getting very good forecast or not very good recommendations. In this case, we monitor them, and when they start drifting, we retweak the model. I think this is a very key component in which we can use the retraining capability to keep the model fine-tuned and operating at its optimal 24/7 all throughout the months. Next slide, please. I don't know, Prabal, if you want to add anything or just take on.
No, I think you said it all. I mean, the change management is the key, and as we all know that it takes time. So I would also like to just finish the slides and also open it up for questions. We went through a lot of integrations, and I cannot just list all of it. So it's a list of OSIsoft areas that we integrate with, and we're continuously increasing our integration with OCS, OSIsoft Cloud Services, and other areas. We deliver this as a service, so that's another thing is that it's 24/7, so that's another thing. So at this time, I would like to start it with the questions and bring it on. I think if you speak on the microphone, he'll be able to hear you.
All right. Any questions? Please raise your hand.
Yeah, there we go. You're in the right place. He can even see you.
So my question is, with the PI system, we're always saying that the PI system is not itself a control system, more for analyzing the data. But in this case, we're using Pi to determine real-time set points and autopilot decision making. So could you maybe comment a bit on that and how you were able to make that happen, and maybe what the risks might be?
So let me clarify it. We determine the Petuum as a service does not run inside Pi. It runs as a service on some cloud services. I mean, we're a cloud neutral company, so I'm not going to mention any names here, but it runs on our cloud services. That sends the prediction. OSIsoft is used as a transport mechanism, not as a decision-making system. Just making sure of that, just clarifying it. So the decision or the AI part of the platform runs on the cloud services. So that's this box. Yeah, actually, I have a slide right here. So that's everything runs on this side. This transport mechanism going directly to the data transfer, Cloud Connect, is used to transfer the data in that direction. And I'll let Rodrigo comment on that.
Yeah, no, I think that it's right. I mean, the PI system is not a controlling system. It's just the means or the platform we use to be able to stream the data to Petuum services and then to receive the data back from Petuum. It's kind of a triple integration in there between CEMEX, Pi, and OSIsoft and Petuum. That's a seamless integration in there.
I just want to add one thing is that, and the reason we also like the Pi system is because a lot of people have looked at Pi as the historical or the historian and then the real-time data. But there's a whole new thing, it's called future data, and that's what we do. When we do the 5-minute predictions, 15-minute and 30-minute, we're sending it back to their Pi server. So that when the operator is opening up their Pi vision screen, they're not only seeing their current data and the past data, but they're also seeing the prediction on the same screen. So those are the benefits that we're using out of the Pi. And then they can do further analysis of that data or whatever recommendations we're giving using different tools.
Thank you.
Question? Oh, there we go.
About having the system in a cloud and the the frequency of sending the feedback for new set points or adjusting the set points, is it good enough for a complete clinker production, since the preheater through the kiln itself and the cooler?
Yeah, we are learning as we go. I mean, we had different predictions when we started for the prediction phase. Now we are going to prescription and auto steer. So we have different predictions for different parts of the system, if you're asking that. So far, it has not come up as a deterrent from being on the cloud. So that has not been the case because of the CEMEX process and all. But we are also, as a company, and this is a CEMEX presentation, but if you're asking about us, we do have also deployments also on site or closer to the things as needed for higher speed operations.
So it will be a dual system.
No, this is a CEMEX presentation. You're asking about us, two different. Just talk to me after this. Okay. With
I'll
CEMEX,
do
we're
it.
using,
I'll
yeah,
do it.
yeah, thanks, yes, yeah. Rodrigo, if you want to comment on the same question.
I didn't get the question very well. It was related on how we got to or how.
No, the question was, I'll repeat it, that are you seeing any problem in running it as a service with the set points going directly to your control system from the cloud?
No, because it's always supervised. I mean, we don't leave it running and then go outside of the control room. The operator is always there. So he's monitoring what's happening, but also we have the central control center in Mexico's corporate office looking over. So we're monitoring constantly. If something is weird, the operator can always switch it off. The experience we're getting, I mean, we're taking baby steps. We're not going full throttle initially. I mean, the first month we're getting autopilot usage percentage, probably 15 to 20% of the time. As weeks start passing by, the percentage is increasing. For in our Mexican site, which is now, I mean, we used the US site as a learning site. The Mexican site, which is more stable, it's running probably close to 65% of the time on autopilot, which is a big boom. And they have only been running it for 3 months now. So it's, in 3 months, they're up to 65%. It's a big step.
And we have autopilot disengage rules if the network doesn't work and all, then operator takes care. Next question.
Yes, it's around availability, and it's touching upon same points that you just left here on the table, and that's the impact of network disruptions. How tolerant is it to these interruptions? Because I suppose you have them. Most networks aren't 100%.
We actually haven't had that of a network, but we actually test it as part of our service. We have this heartbeat signal that goes in, and it's part of our regular testing. When we deploy a model, we test all the way from the heartbeat. So if the network does go down, the AI pilot disengages. It's like your car. If you put the brake on, the cruise control goes off, and you operator has to there. And he has been mentioning this is a supervised operator thing, so which means the operator is still there. This is not elimination of operator, and that's where the change management comes so handy over here.
Okay.
Okay.
Thank you.
Okay. Talk to us.
Was there
Was a question here?
last question, maybe? Yeah,
Okay.
let's go for a last question here.
Okay.
Here, Steve.
Where?
Run. Run, Stephen, run.
Oh, I actually have two questions.
Oh my
The
God,
first one
two
is easy. How long does it take for you to finish the pilot from like installing cloud service or Cloud Connect to getting data to Petuum and deploy, let's say, the machine learning algorithms and prediction back, like the whole thing? How long does it take?
The elapsed time or the time taken to install it? Which one?
Like the project.
Oh, the project. I mean, a new site, like to get the Pi infrastructure running, it comes in days. So it's, I mean, the Cloud Connect, I mean, we have been installing Cloud Connect in hours. So that's not the thing. Because you have to remember, the answer is not true for everybody. They have an enterprise agreement of Pi, and they have the Pi server everywhere. and
We
they
do
have
too.
been upgraded. Yeah, well, you do that too? Okay, that's good. Then it's very easy. If you don't have it, we have great people in OSIsoft that works with us. I mean, we don't go without them, and we call them and then say, hey, here's the customer that needs these installations done, and we'll work it out with you. It is in days. I mean, I'm talking
But
about.
how about the side from Petuum? Like how?
Ours is a service, so we just need to know the endpoint of Pi, and then,
Okay.
then we can connect. Now,
Okay.
development of the model and that's a different issue. That's we need to sit down with the use case and other definitions.
Okay. And my second question is, all those data you get is raw data, basically. So you do the data cleansing, all that part in your
Absolutely, as
system.
part of our
Okay.
service, we look at the data, we do the data cleaning. We, in fact, does a lot of that thing and add different kinds of features.
Okay. Thank you.
Yes, as part of that, yes.
Well, thanks, Prabal.
Thank you for the opportunity.
Thanks,
Yes,
Roberto.